Going to be talking about deploying Synapse with Terraform, infrastructure as code. Quick one about me, John. I do IT, but clearly not desktop support anymore. I used to back in the day, about 20 years ago. Contact details are there. Connect me on LinkedIn. Drop me an email if you think of something after the case. My GitHub's there. I will put up the slide deck and all of the code artifacts after this, so probably by Monday. And I'll post up on LinkedIn as well to say where they are. And my blog's there as well. Haven't written something for a month or two, but there's still some content there, a lot of it about infrastructure as code and so on and so forth. So feel free to reach out. But yeah, I've worked through consulting, spent some time working at AWS, Microsoft, advancing analytics and what have you, data platform specialist, come from an infrastructure background. So what we're going to be discussing today, primarily we're looking at really sort of infrastructure as code and how this can help us when it comes to deploying and standardizing the deployment of, in this case, a Synapse environment. If you're looking at more of the sort of Azure service-based side of things, Terraform's got a wide array of options that we can use, and we'll have a quick look at some of the Halo services as well. And then we'll also start thinking about what the boundary is between infrastructure as code definition using Terraform and what sits really within the development environment with Synapse when we start linking the development environment up to Git, and then working from there and sort of thinking, okay, well, how does that interact, and where do we want to sort of draw that line so that we're not kind of overstepping the boundaries of one and into another space. Okay, so that's an important consideration to think about. So what is infrastructure as code and Terraform? So fundamentally, infrastructure as code is a declarative mechanism for saying, I want some infrastructure to look like this. In the case of Azure, it's a case of I want a resource group, I want a Synapse workspace, I want storage accounts, key vault, app services, SQL databases, all of those sorts of things. They're all sort of objects that we can deploy as resources within the Terraform environment. Now, Terraform itself, essentially, Terraform is an application by a company called HashiCorp. Now, there's a couple of different flavors of it. And different elements, and we'll talk about some of that sort of ecosystem in a moment. But fundamentally, it's a command line application. It's multi-platform. We declare our resources using the declarative HCL language, HashiCorp configuration language, which is a sort of JSON-esque type language. We define the resource, we give that entity a name, we then set attributes of it. And then as we go through, we can reference them and we can build up a project essentially with multiple resources. This is our infrastructure. The Terraform element of it at its core is a command line application, which we can use to then communicate with the Azure APIs. Now, Terraform is written in a programming language called Go. It is open source, and a lot of the providers are also open source. And what it means is that I can take my declarative, my environment, I can say my Terraform plan, and what it will do is it will have a look at what's there and say, okay, well, this is what I will deploy, and you can review that. I can do Terraform graph, and that will give me a dependency graph between the different resources, so I can visualize the infrastructure before it gets deployed. And then ultimately I can say Terraform apply, and that will push that out, and it will create them by basically using the Go SDK. It will go communicate with the APIs, and it will instantiate the appropriate resources within Azure. And what this approach sort of gives us is the ability to say, okay, well, this is what it is. Now, because it's written down as code files and a project, we can store that in source control as well. So we then start being able to version control our infrastructure in a way similar to that we version control our environment. So if you think about it, I've got a Git repository with my Terraform project in for my analytics environment, my Synapse environment. And what that means is that I can then have another repository where I'm doing my Synapse development. And as I sort of require additional components within Azure, potentially, I can update the source code and use CI/CD, so GitHub Actions, Azure DevOps, Bamboo, all of those mechanisms I can use to then deploy and update that infrastructure and essentially bring it under management. Okay. So it's very, very powerful. There are also an array of other products from HashiCorp, which are paid for solutions, which sort of complement it. But we're not going to cover those here because I'm trying to keep stuff where it's no cost. Okay. So the Terraform ecosystem as it stands. Terraform Community Edition essentially is the free bit. And within that, we have the providers. Now, these are the things that are published by third parties. Some of them are first-class providers as well from HashiCorp. And if you go to the website for the providers, you'll be able to see the full library and the registry of them. And what it means is when we write our Terraform files, so the way that I tend to lay my projects out are I have a directory and then I have a providers file. And within that is where I declare which providers I want to use. So it's very similar if you're writing, say, Python or C# or Java. It's the sort of imports or using or whatever section at the top. It's a very similar sort of concept when we think about what we're doing with our providers. So I'll import the Azure RM provider, the Azure AAD provider, the HTTP provider, for example, the GitHub provider, the Azure DevOps provider. And what this means is that I'm then able to utilize the in my case, I use Visual Studio Code, use the IntelliSense there to declare these resources and start working with them because they're going to be provider specific. So one thing to be very aware is if I've got a provider for AWS, I've got a provider for Azure. Fundamentally, my syntax and interaction with Terraform is the same, but the attributes associated with an Azure VM is going to be very different to that of an EC2 VM over an AWS. So whilst you can sort of deal with multiple clouds and build hybrid solutions with one Terraform project, you are still beholden to having to understand the attributes and configuration options for the resource that you're dealing with. Okay, so it's not a case of I can declare a VM or a storage account or an analytics service that's agnostic. It's going to be still very much cloud provider specific, but the syntax in which I'm interacting with it and the mechanism I'm using for building a solution is going to be the common part of that. Now, within the providers, we have two key elements, really. We've got resources. And these are the things that we're defining for deployment. Okay, so what this would be in our case here is, excuse me, we've got resource groups. Now that's a resource. We define that. So essentially I will write the code and I'll say using Azure RM provider, I'm going to create a resource group. I'm going to give the entity within code a sort of symbolic name. And then I'm going to define what the name of the resource group is, where it's located, and whether or not there's any tags associated with it. And then I'll move on and I'll say, okay, well, now I want to deploy a Synapse workspace, for example. Okay, in that sort of situation, I'll then, define the appropriate resource block for Synapse workspace, give it a name. Now you've got to give it a resource group and a location. So one thing I can do there is I can go in, I can specify them, I can type that in, for example. But the power of Terraform really comes in by saying, okay, well, I've got the resource group I want to deploy them into. I will reference that object that I have in code, and I'll be referencing the attributes within it. So essentially, I can then build an implicit dependency between these two resources. So I can say in my Synapse workspace, I can say, okay, I want you to reference this resource group object that I've defined elsewhere in my code, and I want you to use the name, and I want to use the location properties of that. And this is where Terraform, again, has a huge amount of power. Is it essentially understands when you run the Terraform plan or the apply, it will understand that there is a relationship between those two resources and say, okay, well, I'm referencing that one, which means I've got to deploy the resource group first, and then I can go on and deploy the Synapse workspace. So as you get a more complex infrastructure where you have interdependencies between these resources, by referencing those resources, what it means is you can build up that dependency graph, and then it will know where it has to serialize and where it can parallelize resource deployment. So that makes life a lot easier for us. Okay, so I can end up with, okay, I deploy the resource group. Well, that's going to be a serial operation unless I've got multiple resource groups and they can all go in at about the same time in parallel. And then I've got my Synapse workspace, and potentially I've got storage accounts. Those storage accounts may be referenced in my Synapse workspace. And if I've built those into dependency up, everything gets deployed in the right order, and I end up with a consistent and configured environment outside of that. Now, as I said, you can have multiple providers within a project. And hopefully, if the demo works towards the back end of the session, what we have is a situation where I've got a GitHub provider and I've got my Azure RM provider, and I can define and deploy a GitHub repository. So I can set up the GitHub repo, public or private. I can set up whether it's got issues, whether it's got wiki, all of those sorts of properties that go with it. And then I can reference that object in my Synapse workspace when it comes to the Git configuration, for example. Okay, so I'm not just beholden to saying, okay, well, I'm going to do everything for Azure in this one and I have to do another one for GitHub. I can build these sort of composite projects where I need these resources across multiple different services to provide the end product. So in this scenario, I'm using GitHub, but there is also a provider for Azure DevOps. So you can deploy an Azure DevOps project or repository or what have you into your environment, and then that can be linked up when you deploy your workspace. So you haven't got to go and do all of that manually outside of it and do the clicks. In the case of GitHub, there is a requirement post deployment to go in and just basically authorize the Synapse application via the GitHub connectivity. But once that's done, you're up and running. Okay. Now, in addition to the providers, we also have data objects. Now, these are a mechanism for looking up existing resources within an Azure infrastructure or a GitHub environment or anything like that. Okay, so these are really a case of I provide the information to the data object, so I define it in the same way as I would a resource, but really I'm saying, okay, you need to go to this service, this is what it's called, these are the identifiers, this is how you find it, and then pull that back in. Because if I've got existing infrastructure that I want to reference, for example, but not under the control of my project. So if we think about a Synapse deployment, the common architecture, if you're using things like private endpoints, you may, depending on things like your network configuration, you may deploy the private endpoint, but you may already have network environment that you're deploying into. So I need to reference that remote network, that subnet, and the configuration that's sat there. So I can go in and say, okay, well, I want to go and create this data object for the hub network or the spoke network or whatever it is that I'm going to be deploying my private endpoints and need to connect them to, but it's outside of my control. So I can do that, provide the information at runtime via variables or what have you. And then that means I can do the lookup and I can still reference that object into my main deployment. Same with things like DNS, for example. You may or may not have control over those as well. And when we're doing the resource deployments and the data lookups, obviously we're going to need to authenticate and access. So we authenticate and authorize against, in this case, the Azure environment. So what we need to think about there is, okay, well, what permissions does either the service principal that we're using or the account we're using or whatever to be able to access those resources has got the appropriate read, write, contributor, whatever permissions, okay? So just bear that in mind. But that's all wrapped up nicely. I define them in the sort of JSON structure in HCL, and then I can move on. Now, outside of the provider specific, we've got the ability to use variables. So again, in my project, I'll just variables.tf, that's the file I'll use. And in that scenario, I will just put in all of the variables that I need in order to reference into my resources or the data objects. So this is a way that when I run my Terraform command, either apply, destroy, plan, whatever, these are the bits that I can put in to make it environment specific, for example. So rather than hard coding everything into my resources or my data, resource objects, what I'll do is I will reference the variables. So for the name, for example, I'll be like var dot variable name. the variable's defined what it is. I can give it the name, I can put a description on it, I can give it a type. I can also put put the description in there as well, and you can actually have that prompt at the command line. So if someone forgets to put something in, you can give a descriptive response to say, can you provide this particular piece of information, at which point host time. There are other ways of doing that. We'll discuss those in a bit, but essentially I can define the variable set, I can bring that in, I can put validation into those variables as well to make sure they're the right string sort of structure. I can put logic in there to say, okay, well, this must be a sort of value for that. And then be able to take that in and put that to work in my resource providers. There's also various functions that you can use within the Terraform environment. So things like join, various string manipulation functions, logic functions, and what have you as well. So you can build a lot of logic into those. We've got outputs. Now, this is something essentially when we've come to the end of the process, I can define I want to output things to the host. So this will go out to the command line at the end. Rather than I'm not outputting a file, I'm outputting a value to the host. And these can be very useful for into the logs for things like CI/CD pipelines. I've defined my infrastructure and I want to put something into the log. If you got Azure DevOps, for example, you can output things to the pipeline and retrieve those using the various different tasks in that pipeline if you want to use them elsewhere, for example. So if there's other things, you've got a multi-stage pipeline that sets up the Azure environment for Synapse and then goes and registers some things in other places that's not necessarily being done by Terraform. You've got different steps. All of that can be done. You push that out to essentially the command line. You've got the logs, you can then report on it, things like that. Very useful for outputting useful information. If you're doing it interactively as well, it's really good if you're doing that and you want the URLs, for example. Say if you want to go into the portal and manually look for things, what you can do is have the outputs come out to the screen and then they're all there for you. Okay. Locals, now these are kind of like variables, but they're a little bit more intelligent. What I tend to use these for is where I need to take some raw input and I need to do manipulation, and then I'm going to use it in my resources. And so a good example, and it's on my blog if you want to have a look, is around how to name resources. Now, I like standardizing things. Okay, the Cloud Adoption Framework gives you a naming convention. It's a good starter for 10 if you haven't got one. But if you do define a naming convention for the structure of the names for your Azure environment and the resources that you're deploying, what I tend to do is I create a locals file and I define all of my resource prefixes. Again, on my blog, there's a post there about how I've got a Python script that will scrape the CAF naming framework and generate a Terraform locals block that you can use to look up. And I can use things like the join functionality, for example, to say I want to take the prefix from one of the locals blocks. I want to join it using hyphens to other properties that I am putting in through variables at runtime. So, for example, the application name, the environment state, and the application instance. So what I'd end up with would be RG for a resource group dash lakehouse dash dev dash one. Okay, and that's my naming convention. I build that automatically, which means I don't have to go through the process of manually naming things and passing those names in as variables. I can automate all of that naming. And then all I do when it comes to the resource name or the property or the values or whatever, I can then just reference that locals and say, right, go and do the work there, create the string, and then use that. Whereas with variables, it's just a straight case of I'm going to take a variable, I'm going to inject that into that particular property, and I'm not going to do any manipulation. You could, in theory, use the functions in the resource definition, but I would caution against that because the more you can centralize it and reuse stuff or have it in a manageable place, makes life a lot easier. So if you go in and you change a project or you refactor it or start using your own custom modules, then it can get a little bit more complex. Which leads us on to modules. Now, there's a lot of publicly hosted modules and module registries, but you can define your own. And that can be as simple as a case of, I'm going to create a subfolder and I'm going to define a whole pile of resource definitions within that, call it a module. And then when you reference it and deploy that in the main project, which is in the same structure, just at a higher point in the hierarchy. You reference that folder that subfolder structure, and you're essentially then going to pass in the properties needed for that module. And that's a really useful way of abstracting some complexity away. It's a really good way of encapsulating a bunch of configurations so that you can give it to people who aren't necessarily platform specialists. They just want to use the system. They just want to deploy a Synapse workspace and environment, and they want it to look a certain way. And as a standardized one, you say, right, use this module, give it these values, and you're off and running. So again, we can do that ourselves. You can then also externally host them into your own GitHub repos and reference them that way and bring them out under source control. So if you have got, when you really sort of start to invest in Terraform or infrastructure as code, you can build your own library of modules, and then you've got that ability to just pull them in as needed, and you can host your own library of modules as well. There's the back end. Now, the back end essentially is a mechanism for state management. And this is where it starts to really sort of get a bit better compared to things like Bicep. When you deploy Terraform, it creates a state file, which basically says, this is what I deployed and this is what it looked like. Now, if you are going to manage your environment with Terraform and infrastructure as code sort of methodologies, you want to make sure you've got that state file somewhere secure. And you can either put that into cloud storage, you can use Blob Store, or you can use Terraform Cloud. Now, there is a free tier for Terraform Cloud. Beyond a certain number of resources, I think it's about 1,000, then you have to pay for it. But essentially, it's a web interface that will show you, this is the project, these are the resources that are associated with it, and you've got some control over how you're then going to deploy them, storing plans, storing state files, all of that sort of information there. What that also does allow you to do is start doing drift detection within your infrastructure. So if someone is going in and manually reconfiguring things, you have got the ability, because you've got a state file for what was a known deployment, to be able to compare it against what it does have, what's in existence at the moment, and cross-reference them and say, actually, someone's making changes, the infrastructure doesn't look like it's how it's supposed to, and then you can take the appropriate action if you need to. You can either then do an apply over the top and say, revert back to what I need, depending on what the changes are that have been made, as to whether or not it's going to have to destroy and replace a resource, or if it's just going to do an in-place update. And that's something that's really important to understand when you start looking to automate infrastructure as code, is you want to have manual authorizations. It's not like a continuous sort of delivery, continuous deployment sort of scenario, because if you put in a typo, for example, and you want to rename a workspace, then that's a destroy and then create option. And obviously that's going to have a big ramification for your data. Okay. So well worth exploring that. And then there's the additional pieces that sit around Terraform Vault, which is kind of like Terraform HashiCorp's version of Key Vault. So secret management, secret storage, Packer, which is good for image management if you're using containers, VM images, that type of thing, and Console, which is virtual networking. Okay, but they're outside of the bounds of what we're going to talk about today. And that's what we're focusing in on, is the Terraform open source piece and the free one that we're looking at. So we start thinking about what a typical Synapse deployment looks like. We've got the workspace with or without secure networking. More often than not, probably secure networking. So private endpoints and so on and so forth on the VNets. The storage accounts, everything like that will have secure network endpoints as well. So just make sure we can deploy all of that. Storage accounts, I'm a big fan of putting standard blob store and ADLS in there as well, but whatever you want to set up. But we can do that, but we have got blob storage of some form. Invariably, there's a key vault in the mix as well. Now, this is an interesting one as far as I'm concerned. What I tend to look at doing is saying, I want a key vault per application. And when I say per application, I'm essentially saying if I've got Lakehouse 1, which is a brand new lakehouse, then it will have its own key vault. We won't have one key vault for the whole business. We won't have one key vault for all the environments. So essentially, this is the dev application of, or the dev version of Lakehouse 1. That's got a key vault. The test application of Key Vault 1 will have a key vault. and then the prod one as well. So you end up with more and more of them. But you think about the boundaries, who's got access to the secrets and what they're going to be doing. You kind of don't want to interleave them. You haven't quite got that granularity of RBAC in Key Vault, which is somewhat of a deficiency in that particular product, in my view, but there are ways around it, like I say, with the way that we create the key vaults and manage them. And Git source control, and this could be DevOps, this could be GitHub. So there's a couple of different options that we have available to us there, but that's by and large the core elements of a Synapse deployment. When we start thinking about that, we've got our lakehouse in the middle there. So we've got Synapse and storage, version control. We have Halo infrastructure, what I term as Halo infrastructure. These are the things that sit around it and act as enablers. You could sort of these ones here kind of span, could go in here depending on how you want to look at doing your diagrams, but essentially that's an element that sits there. But we've got the standard resource groups and other resources. We've got Entra, which is obviously used for a lot of our identity, whether it's service principals, managed identities, user accounts, all of those elements that we need to be able to grant access to different resources and how we're going to set that up. We've spoken about Key Vault as well. That sits there. We have our data sources, and this could be APIs, it could be Oracle databases, SQL databases, Postgres databases, files, it could be other Synapse environments, it could be, for example, you could be setting up Synapse Link, and we've got Dynamics out there, but essentially we've got our data sources, and then we have our presentation layer as well. Power BI, Fabric, whatever you want to look at, Tableau, you name it. And as far as we're concerned today, from a deployment perspective, if I can get the demo to behave and get my screen shared for the last few minutes, we'll have a look at the way that we define and set up the resources in the Terraform files. So let me see if I can just share my screen. We'll give it a quick go. Andy, if you're still there, let me see if I can share up my VS Code.
Yes, I can see it.
Yes. Right then. That's a bonus. Do you need me to make it larger? We'll make it larger.
I'm okay, but you could, yeah, that looks fine to me.
Right. So within my Terraform directory, as you can see here, I've got different files, and they're just suffix TF. And I've got the Terraform extensions added to VS Code, which is why they're recognized as Terraform files. So tagging, what we do here, this is actually start providers. So what I've got here is the required providers for the project. So I've got Azure RM, GitHub, AD, HTTP, and random. Okay. And you can see here I'm specifying versions. My preference when it comes to setting up the projects is to specify a static version, not a minimum version, because what I do is when I come to do a release, then I can consciously basically make the change to a current version, because then I can do the tests and I make sure if things work. I don't want random failures and automatically incrementing the version of the providers. I'm just a bit of a control freak when it comes to that, is I want to know exactly what's gone out the door. So I will consciously update those as needed based around my releases. And then we come down if there's any specifics for authentication. Now, for Azure RM, I'm just doing it interactively through my Windows subsystem for Linux. So I'm essentially using Azure CLI to authenticate. But here you can set up things like the ability to say, I want to specifically pass in the tenant, the subscription, and that sort of information about what I want to connect to with Azure RM. And then you can pass them in as environment variables on your build servers or what have you. Here I'm passing in my GitHub token. So this is a personal access token to allow access to my GitHub repository or GitHub accounts, sorry. And I've not got anything specified here for any of the others. But that's what our core providers element looks like. And this says this is what we're referencing. And then resource naming, as I said about some of the locals. I've got my naming TF, and I've got a locals here where I've got 3 typical names that I'm looking at. So I've got base name, and this is one where I can take the variables in. We'll have a look at those in a moment. But I'm taking application name, environment, region, and application instance. I'm joining them together with hyphens, and I'm making sure they're all lowercase. So I'm essentially setting a format for my names. Safe name, this is one where it's actually got no hyphens in. And that's for things like when you consider storage accounts, for example, they've all got to be lowercase, no hyphens, and there's some other restrictions. And that's what you want to start thinking about. We can standardize that and build in these protections so that we're not ending up with issues. And then an underscore one, which is always useful for if we're deploying Azure SQL databases. Down here as well, we can see here are the prefixes. So if we come down here, Stream Analytics, Synapse Workspaces, so SYN W is what our prefix will be. Now, when you come to the naming for resource names, this is where I'll essentially come across and say, I want to, for my resource group name, do this. I want to look up the resource group prefix and join it to the base name. Synapse Workspace, find the prefix, join it to the base name. Storage accounts, safe name. Okay, so again, I've done that there, which means when I come into my resources, which I'm going to put in main.tf, we'll have a look at these. Resource, that's my GitHub stuff, which we'll talk about in a moment. But essentially the base resource group, Azure RM resource group. So that's what I'm deploying from the Azure RM provider. I've given it a name of RG_Lakehouse. Okay, and you can see here that I'm calling the local resource names resource group name. Essentially, I've got an array of values that I could be calling, and I've got var.azure region. And when we think about the variables, here we go. I've got all of these declared here, so I can set the types. There's the description, so that's what will be prompted at command line if we have to. And then there's also the ability to come in. Here we go. There's one with validation, for example, where I can say the condition is it's got to contain dev, test, stage, or prod. And the value that I'm looking for is the environment. Okay, so this sits within the variable declaration. So this comes in and it's got to be of one of these values. Otherwise, it's not something I'm going to accept. So again, I can start standardizing things. There's the region string. There are some, here we go, GitHub token. Rather than passing in a runtime, so putting it in a variable file or having to put it in the command line, I can instantiate it essentially as an environment variable. Now, if I prefix the environment variable with tf_var_ and then the same name as it is the variable, then it will implicitly link the two together when I do the apply or the deploy or whatever, so that I don't have to go and put those in. So if we look at my tf_vars file, now this essentially is an answer file, if you will, that says, okay, what do I want it to do? What do I want to pass in for the value of these variables? So I don't have to put them all in a command line. I can specify a configuration file like this and then just pass a reference to this file. And it, so long as the variable name here matches what I've defined in variables, it will take this value and apply it. Okay, so we can see, okay, I'm going to do containers. I'm going to create a blob storage. There's my Key Vault configuration. There's my Synapse Workspace variables as well. Is Git enabled? And this is an interesting one that we can do here if we come back as well, because we're not going to obviously want to put the Git enabled in our sort of upstream ones. We want to put them into our down. So the development environment will have Git enabled. Upstream environments won't, because we're deploying from that one. So if we come down to here, that's where we put tags in as well. If I come down to, where's my Synapse Workspace? Storage accounts, eVault, Workspace, here we go. So this is where I can start specifying it. And you can see I'm using locals. This is where I'm referencing other resources. So I'm looking up the name of the resource group and the location of it. That builds the implicit link between them. I can use the random one to create a password. I can use, where is it? Firewall. I can create a firewall rule by using the HTTP provider. I can essentially jump out to a web service that gives me back my public-facing IP address to be able to set that up as a firewall in this case. But this is the bit that also starts getting interesting. We've got dynamic element to it. So the GitHub repo, if GitHub enable is true, then we actually use the GitHub repo information. So we pass that in. If it's basically set to false, which we'll do for test, prod, pre-prod, whatever, then it won't actually set up any of the Git configuration in those as well. So we can use this one format and this one project to deploy both sets of the environment, okay, just by providing different variables. Cool, right, so how does all this help us? Automation and deployment, multiple environments, they all look the same. Environment specific parameters, like we said, so you can say, I want my prod one not to have Git configuration, I want to have a particular naming, and infrastructure changes to our analytic product and things like that. We want to bring extra things in, or we add extra capabilities, or we need extra requirements, and we're making change with development. We can link all of those together and make them part of release pipelines. So in summary, infrastructure as code is a great way of adopting a standardized deployment mechanism. So everything will look the same. So from a support perspective, it makes life a lot easier. From a test perspective, you can roll the same changes through. You're not got a person in the loop. People are fallible. We make mistakes. That's how I've learned a lot of lessons. If you're doing everything sort of by hand through the portal, or you're doing PowerShell scripts, it can be a bit onerous, and there's a big opportunity for mistakes. If you define it as Terraform, you end up improving the sort of reliability of those deployments. Identify where IAC stops and source control takes over. And this comes into things like you can deploy linked services through the Terraform element, but really that's something you want in source control, so you don't want that in your upstream environments. Certain things you have to deploy, and that'll be in the live environment in dev, not the Git one. So you can import them, or you can define everything in Git, do it that way. There are lifecycle blocks, and you'll see when I publish the code, essentially I can say ignore changes to this thing. Okay, so there's some things you can say, this is out of bounds, this is going to be manual, this is going to be managed manually. And then track state and drift detection in your environment. This makes a really sort of good compliance play. So has this changed? When does it change? So if you've got a check every sort of 6 to 8 hours for drift detection, it's possible to do that. And then you can say, okay, yes, there's been a change. You can then drill into the logs and have a look. Okay, so it's something that can be very, very useful. And with that, thank you very much for the time today.